Okay. Above we talked about ARP. Perform ARP requests. On the same network segment, you can directly request the destination. For example, PC1 and PC2 are the same segment. All are 1.1.1.0 network segment. You can directly request. The ARP cache table is cached locally for the current data. If every data communication, an ARP must be sent before communication. This is not optimal. Now on the internet, the number of messages sent is actually a lot. For example, I now have a relatively large message. Maybe a few G. If I watch a movie, then it is necessary to continuously send messages. Each packet actually has a specified size. That is, the message will not be particularly large. For each data packet, it has a prescribed value. We call it the MTU value of the link. I told you this before. For data, data is being sent continuously, sending from source to destination. Many messages may be sent at the same time. Keep sending. Then if every packet sent, data encapsulation. That means, for this purpose MAC is to be used frequently. If now every time before sending a packet, make an ARP request. It's not optimized. Very troublesome. So now, we designed an ARP cache table. Exist locally. You often have to send data. This ARP cache table will always be refreshed. Otherwise it may be aged out. Because it is a dynamically learned representation. This is enough for everyone to understand. So let me give you a summary of the process I just talked about. If the PC now communicates with the peer, it will compare. Is the IP address of the peer end suitable for you to be on the same network segment? The way to compare is your own mask and your own IP count as your own network segment. The other party's IP and its own mask are counted as the other party's network segment. Please pay attention. What we just said. They work out the same. They go through. But it's not work out the same. This will involve ARP. Now the data is the same. Data from the same network segment. As it can be sent. And be able to reply to it. Then before sending the data, it needs to investigate the other party's ARP first. That is to say, use ARP to investigate the MAC address of the other party. Before actual communication, it will detect the mask of the peer. Are you in the same network segment as yourself? If the two are considered to be in the same network segment now, then it borrows the ARP to achieve overall operation. That is, borrow ARP to capture MAC address. Only after that can the MAC be packaged. Then proceed to the next step. Implement this operation. Then send an ARP request. The other party will reply with an ARP response. This is the query we're talking about. But actually, before we borrowed ARP to achieve MAC address capture, first, check the local ARP cache. Everyone should know this. Certainly, ARP must be sent the first time. But the follow-up will first look at the ARP cache. Wait a minute to show you. In the current cache, if there is a corresponding relationship between the corresponding IP and MAC address, now you can directly encapsulate the data. If there is no local cache, then ARP will be used to capture the address. Let's take a look together. Still PC1 and PC2. Let's look here first. I make a mark here. Everyone will find. There will be no more packets. Let's ping now. Here it reappears a set of ARP. The content is the same as above. It's all a request. Then a reply. But for the following. Now, the 5 packet encapsulations have been completed. That is, we pinged. Ping back. ARP is back again. ARP is now aged out. So let's do a new test now. Watch carefully. I'm still here to make a mark. Now if I take PC1 to ping PC2 again, this yellow ARP will no longer appear here. Only pink messages will appear. I only send ARP now that there is no local cache. Then after sending, there is a local cache. Save the 005079666802 corresponding to 1.2. I won't post it now. Let's test it. Ping 1.1.1.2. Okay. We captured new data. But in this data, it seems that it really does not have this group of ARP packets. This is the markup I just made. The only thing left is the message of the ping command just sent. There is no ARP. Actually, when it is packaged, I have found that there is a MAC corresponding to 1.2 in my cache. So it directly encapsulates. If the lookup table does not, it will do this. Next, let's talk about some slightly more difficult. For the gateway, if it is the same network segment, then communicate directly. If there is no local, just request the MAC of the corresponding destination IP. But let's think about a question. What if it is across network segments? ARP message is a broadcast message. It is delivered within a broadcast domain. The second floor is all F. But for routers, each interface is a broadcast domain. That is, if the future PC wants to send from 192.168.1.100 to 192.168.2.100, that's actually going to the opposite end. May I ask how to package the MAC for this purpose now? ARP is now a broadcast packet. But each interface of the router is a broadcast domain. This is the range to which broadcast packets are delivered. That is, if PC1 sends an ARP request now, only this interface of the router can be reached at most. It won't be forwarded here. This device cannot receive the request from the device on the left. Then it will naturally not reply. Logically speaking, if it doesn't reply, there is no way to encapsulate the second layer. If now they are data forwarding across network segments, then the second layer will encapsulate the MAC address of the gateway. PC performs calculations locally. Compare whether they are on the same network segment. It finds that it is not in the same network segment as the peer device. So now when it is sending ARP packets, no request to the peer device. Instead, request the MAC of the IP address of the gateway. That's what we just said. The target IP in the message will become 1.254. Target MAC is the MAC that requests the interface of the gateway. Because for PC access across network segments, it will go to the gateway. This is its gateway. Then since the PC now knows it is not in the same network segment as the peer device, as long as there is now a gateway is configured on the PC.